So we're going to talk about physics-based interfaces with UIKit Dynamics. I'm Sam. This is Adam. Both Adam and I work at Livefront. Livefront is a very small team of designers and developers, and we build mobile apps for Android and iOS. We've got a couple really cool new projects starting up soon, so if you're a contractor and you're looking for work and you want to work with an awesome team, feel free to talk to any of us. There's lots of Livefront people here today, so we're looking for help. Adam and I also both teach a class on iOS at Smart Factory. Smart Factory is a school offering courses for developers and designers that want to either improve their skills or learn something new. So if you're an Android developer and you want to learn iOS, that'd be a great place to do it. If you want more info, talk to either Adam or myself or check out smartfactory.com. It's a lot of fun. OK, so let's get into it here. I'm going to start off with a little introduction to physics-based interfaces, just talk about what they are and why you might be interested in them. Look at a few examples of apps that are in the wild that are using some kind of physics in their interfaces, and then a little bit of a deconstruction to take some of those examples or one of those examples and kind of break it down and talk about how we might implement that using UIKit Dynamics. Adam's going to talk about collection views and lots of other fun things. And then we're going to talk about limitations and gotchas, just some things that we ran into while we were working with UIKit Dynamics that we found interesting. So first up, physics-based interfaces. I'm excited about this next slide transition, so I feel like I need to build it up a little bit. Thank you. So we're talking about basically just building interfaces that kind of simulate real world like physics with classical mechanics, or here's the definition for classical mechanics, also usually called or sometimes called like Newtonian physics. This is from Wikipedia. Physical laws describing the motion of bodies under the action of a system of forces. Really, we just want to show things and interact with things in a way that makes them seem like they're real. So like dragging something across the screen, maybe there's some friction or elasticity to the movement, something like that. So that's kind of the focus for the type of thing we're talking about and what UIKit Dynamics is built for. So little background on UIKit Dynamics. This is a new part of iOS, starting with iOS 7. It's not a separate framework like some of the other components that you might use when you're building iOS apps, and that actually makes this really cool. It's just built into UIKit. So anywhere you're doing animations or using UIKit at all, you have this physics engine built in, so you can just make use of it. It's just kind of hiding there in iOS. And this is a little bit of a tangent, but kind of cool. You can actually use it for anything you want. It's kind of like you have a physics engine at your disposal. You don't actually need to use it for things you're displaying. And I'm not sure why you might want to do that. We're not really going to talk about that in this talk, but you just have this capacity built into iOS to do these kind of physics simulations. So that's really cool. You can use it anywhere you're using UIKit. I like to think of this as, it's just part of UIKit, so it's just something you should get familiar with as an iOS developer. It's not appropriate for everything, but there are lots of times you're doing animations, and it would be cool to have a little bounce to it or elasticity or something. UIKit Dynamics is a really, really easy way to get that kind of nice animation and interaction. I think one of the things I find really appealing about it is that we're always downloading apps from the App Store, and kind of you see some animation or some feature of the app, and you're like, that's really cool. I want to figure out how to do that. Or is Andy here? Andy might not be here. Or Annika, on the Livefront team, the designer might download an app and show you this cool feature, and they're like, we really want to do something like this. And you're like, yeah, that's really cool, but that's going to take like 3 years and a physics PhD or something. But UIKit Dynamics just kind of gives you the opportunity to do those types of things really easy. So, OK, so iOS actually introduced a couple of interesting physics-based interfaces back with the original iPhone in 2007, and I just wanted to highlight those to kind of set the stage for the types of animations we're talking about, just as a kind of a visual reference. So this is a video of iOS 7, but these two things I want to point out were introduced kind of as really interesting innovations with the original iPhone. So the two things in this video are, one, the kind of flick scroll with the kind of natural deceleration. So it kind of flicks the screen down and it naturally decelerates. And the other is when you pull to the top of the list, you get that kind of elastic bounce to say there's nothing else to view in the list. These two things have been part of iOS and lots of other little features as well since the beginning. And now as iOS users, at least, we kind of take this for granted. It's just part of the way we use those apps. This gives really great feedback. It's just a nice kind of innovation that no one else was really doing, at least on mobile devices. Unfortunately for the world, Apple patented this stuff and is kind of pursuing, suing Android and other platforms to prevent them from doing some of these types of things. So if you're an Android user, you probably, seen other ways that the OS is kind of trying to do similar things without these specific types of behaviors. OK, some more examples. These are from just apps downloaded from the App Store. This is an app called Tweetbot. It's a Twitter client. I'm going in to edit the account edit view here, and when it pops up confirmations and things, you can see a little bounce with the buttons. Just really cool, really tiny UI elements that just make the app fun to use. This is also Tweetbot. When you tap on an image, it gives you a full screen view, and you can actually tap on it and drag with your finger. You can't see my finger, obviously, but I'm just dragging the photo around. And then if you flick it, it kind of flicks off the screen and dismisses. There are two kind of physics things going on here. One is, as you drag the photo, it kind of slides around like a normal, like a sheet of paper on a tabletop would. And the other is there's kind of a fling where it just goes spinning off the screen, which is kind of fun. This is just the lock screen. There's gravity on the lock screen, so if you tap on the photo icon and drag it up, if you let go, there's kind of a bounce. It doesn't just slide down in a steady manner. This is the Beats mobile app. Beats Music mobile app. When you first set up your account, you get this kind of goofy interface to select the genres of music you like, and as you tap on these bubbles, they get bigger. It's kind of fun. Kind of bounce around a little bit. This is an app called Ballin that is a Dribbble client, and you can look at people's art from Dribbble in this app. And you can tap your finger and pull down, and it has a nice little interaction there. I should note that we don't actually know what they're using to do these effects. This one looks like UIKit Dynamics just based on the way that the image bounces, but they could be using they could have written the code themselves, These are just not specifically UIKit Dynamics examples, but just examples of other physics-based interfaces. This is an app called Up Coffee, where it tracks how much caffeine you drink and then tells you what time you'll be ready for bed. I guess those are little caffeine globules. I don't know. This has a cool interaction where you can't see it in the video, but the sloshing back and forth was due to the phone being rotated back and forth. Mm-hmm. OK, so let's dive into some technical stuff here. Just a recap on UIKit Dynamics. So this is going to allow us to build natural, real-world kind of physics-based interactions. We don't write very much code at all. In fact, when we go into the code, there's quite a bit of code for some of these things we're going to look at, but the UIKit Dynamics specific code that's dropped in there to do the animations is really tiny, and maybe it's 10 to 20 lines of code, depending on which interaction we're looking at. It really is a beautiful API. It's a lot of fun to work with. It's really well designed, and Adam will talk a little bit about this too, with how it works with collection views and why that is so kind of seamless in iOS. It's fun, and importantly for some of us in the room who had to take physics more than one time in college, no knowledge of physics is required to use it, so that's kind of cool. So here's a really simple example. Say we have this interface where we have these blocks and we want to stack them on top of each other like this and just have them sit there due to gravity. We can use UIKit Dynamics to simulate this type of scenario. This is really basic. Obviously, there's no interaction here. There's no animation. We just want to create this kind of these building blocks. First thing we need to do with UIKit Dynamics is create a dynamic animator. And this object is kind of in control of the physics simulation. It knows about all of the components of the physics that are going on in this particular view. And it has a reference view, and that reference view, in our case, it's just the container view. And that helps with collisions. You can set boundaries on things. It basically just is a container for where all the physics stuff is going to take place. And if we want gravity, we can create a gravity behavior. This is built into UIKit Dynamics. We just create that behavior, and we tell that behavior about all of the views that should have gravity. In this case, that's all of the views, all of those 3 blocks. Basically, we want to give gravity to each one of those. That seems like it might be enough, but we're missing one thing here, and that is that we haven't turned on any collisions. So we'll see in an example later, if we had a view like this, those blocks would just fall through the bottom of the screen, and they wouldn't bounce off of anything. So we need to add one more thing, and that's a collision behavior. So our dynamic animator has 2 behaviors, gravity and collision, and both gravity and collision just have references to all of the other views in this demo. And that's basically it. That's all we need to do to get physics in our app. Those views have a couple of special properties. They're not just normal NS objects. They actually have to adhere to UI dynamic item, UI dynamic item protocol, and that allows the physics simulator to kind of know certain things about them, like their position, their size, all of that stuff that it might use for collisions. UIKit takes care of that for us, so UI view automatically abides by this protocol, and so do collection view layout attributes, and Adam's going to talk about that a little bit. So these are the 2 things in UIKit that are automatically dynamic items for you. You don't have to do any extra work to get that behavior. So let's talk a little bit about the different behaviors you have available to you. We talked about gravity and collisions. Those are based on a base class called UI dynamic item, or UI dynamic behavior, and the behavior is generic. It doesn't really do much for you, but sometimes you might want to use it to add elasticity or maybe some friction to an object. It has some kind of basic properties that you might want to assign to any UI dynamic item. So we've talked about these 2 behaviors. There are 4 others. Attachment behavior allows you to attach 2 objects together. You can think of just like a stick attaching 2 objects together, so when you move one, it might drag the other one. Dynamic item behavior, that's not the, what is that one, Adam?
That's like adding properties to a particular item, so like angular resistance or...
Oh, okay. So maybe let's back up a second. So I think that's what I was thinking of here. This is more for if you wanted to build your own kind of collection of behaviors. You could combine them together.
Right, and it's the base class for all the ones.
It's the base class for all the other ones. OK. Sorry, is that? I think I misspoke there. Is that clear for everybody? OK. OK, so dynamic item behavior, that's where you can add different properties to your objects. Push behavior, you can give something like an instantaneous acceleration or continuous acceleration. You just kind of assign a push to it. And snap behavior allows you to specify an endpoint for an object and let it snap back using the physics simulation. So you might get some elasticity or some bounce or something, but the snap behavior just allows you to really easily move things from point to point with simulated physics. So that's it. You can build your own. You could build your own based on that base class and do your own physics calculations, and you can actually recalculate your own simulation on every tick of the physics simulation. So if you wanted to go crazy and implement something that isn't listed here, you could certainly do that. Yeah?
The push and snap are temporary, right? Do they vanish when they're done? Are some of these time dependent and delete themselves, or do you have to kind of worry about like cleaning up a push that's finished pushing?
That's a good question. Yeah, you may have to worry about cleaning them up, but the simulator, the physics, UIKit Dynamics tries to guess when your system is at rest. So if if you have a push behavior that's an instantaneous acceleration, as soon as that object stops moving due to friction or some other reason, then the simulation will basically pause, and that push behavior will still be there. It will still be part of your hierarchy, but it won't actually be doing anything. It'll just be hanging around.
So it doesn't CPU if it's done, but I might worry about creating a push for every tap and adding more and more pushes to my own.
Yeah, I think it's, Adam, feel free to chime in. Oh, go ahead.
Well, you can create systems that will never achieve equilibrium, and it'll just keep going, going. But you would have to actually remove that behavior from the animator if you didn't want it to be there. You can disable them too, I think, but it's like
I think what I've found, and I'd be curious to hear what you think. Has anybody else worked with UIKit Dynamics at all? Okay, a couple people. I think it seems really common to add and remove different behaviors just in your code as you're building out a simulation. So it seems like, at least when I was working on it, that was pretty common. It wasn't as common for me to just create something and leave it there and never touch it again. It seemed like it was just natural to kind of constantly be shifting things around. I don't know if you found the same thing.
pretty much, the exception being gravity, because
Okay.
it only allows you to have one gravity, and if you try to get creative with that, it's not happy, so.
Adam, any other thoughts? No? Okay.
Explaining it well.
Okay. Okay, so these are all the behaviors we have available to us. What am I going to demo? Let's look at, this is sample code from Apple. Uh-oh. How do I get rid of the Chrome? Someone help me?
Control 1 or Command 1 or Command 2, I think we'll resize it to, and maybe even 3.
There we go. Thanks, Paul. Okay, so this is sample code from Apple that just shows each one of those behaviors and how they work, just to get a visual for, it's going to be way better than my explanation. So here's gravity. And here's collision and gravity. Attachments, so this point here, this rectangle is attached to this blue point. So if we move this around, it kind of drags that square based on the attachment point. So now we have some springiness to that attachment point. Anywhere I tap is just going to be the destination to snap to for that object. And you can control the damping, which controls how much kind of resistance there is to the snap to get the bounciness just the way you want it. So here we're creating a force based on the center of the container view, and the further that I think the further that I go out, the stronger that instantaneous force is. It looks like there's no friction or anything on this object, so it'll probably just keep moving until it, maybe a little bit of friction, yeah. And then here's a continuous push, so now that force is just constant. It doesn't fade away like the instantaneous push does. This is just demonstrating that you can change the way things interact in the physics simulation by changing their elasticity or various other properties. What are some other properties? Anything off the top of your head, Adam? There's a handful.
Yeah, I mean that's elasticity, and then there's angular resistance, linear resistance. So.
Okay. Okay, so let's look at one of the examples we looked at before and talk about how we might actually build that with UIKit Dynamics. So we're going to pick this example where the photo here can be dismissed by flicking it off the screen, and you can tap on it and drag it around, kind of slide it around the view. Well, let's talk a little bit about that, actually, what our plan of attack would be. We're going to use 3 behaviors for this. The attachment behavior for tracking the finger movement and moving the photo around. Push behavior to kind of fling it off the screen. And then snap behavior if we don't consider that to be a fling. Maybe the user moved their finger a little bit, but they're not actually flinging it off the screen. We'll use snap back to kind of bounce it back into place. So first thing we need to do is create a UI dynamic animator. And remember, that's going to basically contain our physics simulation. We'll use a gesture recognizer to recognize when the user taps the screen and track where their finger goes. As the user moves their finger around the screen, we'll update the attachment behavior's anchor point. And then after the gesture's over, either we snap back or we dismiss the image with a push behavior. So let's look at the source code for that. All right, so the first thing we're going to do is create a dynamic animator. And we're just going to keep a reference to this animator and use the same animator throughout the lifetime of our view, or at least while the view's on screen or in memory. So as soon as the view loads, we create that dynamic animator. And the only thing really to note here is that we're passing in this view controller's view as the reference frame. So the physics animation is confined to this particular view that's on screen. Then we set up a gesture recognizer. There's nothing special about this. This is just a normal pan gesture recognizer. And we're monitoring that gesture in the view for this view controller. Excuse me. So while the user moves their finger around, we need to do a couple things. One of the things we need to do is create an attachment behavior. And we'll start with, oh. OK. The line breaks are a little funky because of the size of the screen here, but we're creating an attachment behavior, and we attach it. We're basically attaching the image view. So that's the view that's zoomed in, the image that's zoomed in. And then we're attaching it to the anchor point based on where the user's tapping the screen. So we just create a variable. If I scroll up a little bit here, we're just creating an anchor point variable that's just based on where the user's finger is based on the gesture. So as the user moves their finger, we also need to update that position. So we have a reference to our attachment behavior that we just created when the gesture started. And now as the gesture moves around, we update the anchor point to the new position. And that's enough for us to actually move the photo around based on the position of the user's finger. One thing before I run that code, let me see if I have a version of the code that doesn't have it enabled. OK, so this is the app. This is the demo app. All the source code's on GitHub for this. It really is just a collection view that shows a bunch of images from your photo roll. Right now, in the state before I uncommented the code, if we tap on this, I'm clicking, and we can't move it around. It's just a static UI image view. And the UI image view takes up the whole real estate there of the view. So if we run the new version, we should be able to at least move that photo around a little bit. OK, so now we can move it around, but you can see that it's not sliding around the way we would expect. In fact, what's happening here is that we've attached our attachment behavior to this image view, but by default, the point of attachment is the center of that image view. So no matter where we tap, you can kind of see if you imagine a circle around the center point of that image, which is roughly where the sun is, you can see that I can almost go around in a circle without moving the photo. It's kind of like if a stick was attached to the center of the sun there. So we need to make a small change to actually get this to behave the way we want. We really want the attachment point to be where the user's finger is, not just the center of the image view. So I'm going to comment out this first attempt here where we created our attachment behavior, and instead use a slightly more complicated version. And all that this is doing is a really quick calculation to change the click point where the mouse cursor is by an offset. It basically is that distance to the sun there in the center of the photo. So we get the center point of the image view and calculate an offset based on the user's tap. And then we call a slightly different method when we create the attachment behavior. We can use this version that allows us to specify an offset from center. So now we get a much more kind of realistic drag motion. And we can just keep dragging. We need to do a little bit more here to actually get some interaction. So what we can do is we can track the user's gesture while they drag, and then at the end of the drag, we can determine, is this a fling? Do we want to push it off the screen, or do we want to snap it back to its original position? And we'll do that in this block here at the end of the gesture. There's quite a bit of code here. Don't be intimidated. It's fine.
The font's so large.
It really does look like way more than it actually is.
Really productive.
Yeah, it does. Yeah, I'm just going to leave my font size this big, I think. Okay, so just really quickly, I don't want to spend too much time on this. This source code is all available if you're curious and want to dive in more. It's on GitHub. But we want to do two things here. First, we need to determine how fast the user's swiping their finger. And then we need to come up with some way to say whether or not that's a fling or that's not a fling. From the gesture recognizer, we get the x and y velocity. And we get that velocity of the movement in points per, right? Yeah, points per second, I think, in the x and y direction. And we need to turn that into, or we just want to test the magnitude of that. So we do a quick calculation here to get the scalar dot product of the velocity to determine the magnitude. And in our case, this is based on trial and error. We just want to set an if block here and say if it's more than 1,500 points per second, we're going to consider that fling. And if it's not, this is all still in the if block. If it's not, then we will do a snapback. So if it's a snapback, we create a snap behavior on our image view and snap it back to the center of the container view. And this damping value kind of controls the bounciness. So let's take a look at that. So if I let go here, there's no acceleration at all because I'm not moving the mouse cursor. It just kind of snaps back into place. And just for fun, let's change this. It's probably one of the most fun things, I think, about dynamics is that you can just play with these values and get some really goofy, kind of funny things.
Does snap behavior restore the orientation too? Is that a...
yeah, I guess it does. That's a good question. Yeah. What?
Yeah,
Any?
There is each item, I think by default allows rotation, but you can turn that as well per item. So.
Study camp.
Yep. Okay, so that's snapback. Let's talk about the fling gesture. So really what we're interested here, there's a little bit of math up above, but really what we're interested in is this push behavior. So we're doing some calculations up above to get the push direction, the offset from center, actually just those two things. So we're doing an instantaneous push. Sorry about the line breaks there. And here we're adding our push behavior to the dynamic animator. Push direction is just based on the x and y velocities from the gesture recognizer, and then offset from center is calculated the same way that it was calculated before. So let's see an example of that. We're still not quite all the way there yet. What we really want to have happen is that when that photo goes off the screen, we want to pop the view controller and go back to the gallery. So we need a little bit of additional code to do that. This is one place where we're using the generic base class, just a plain old dynamic behavior. And what we're going to do is check, do a really simple calculation. So this generic base class has an action block that we can specify. And this action block will be invoked on every tick of the simulation. And we can run arbitrary code there. We want to be careful here. We want to do something that's not super complicated because we don't want to bog down the system since we don't know how often that calculation is going to be made, but it's probably going to be made pretty frequently. In this case, we just do an intersection check to make sure that the image view is still intersecting with the container view. And if it's not, then we invoke a transition and pop the view controller from the navigation controller. I kind of like the slow ones. That's it. Any questions about that? OK, so how is our time? I think we should switch for sure, right?
30 minutes. Yeah.
OK, I'm going to hand things over to Adam, and he's going to talk about collection views.
What? Yeah. Laptop swap.
if you hit the green plus button, it should. Yeah.
All right. So, collection views and UIKit Dynamics. It turns out that these APIs work really nicely together, and a lot of that just has to do with Apple, in my opinion, in this case, coming through and thinking a lot about how new APIs, especially on iOS 7, interact with each other. And I think it's just, my only point, I guess, is that I think this isn't always the case. You know, a lot of times new frameworks come out.
Sorry about that.
That's right. And they don't always work well together. And I think we're just sort of left to try to, you know, deal with that, like try to take these two things that weren't really designed to mesh nicely and figure out how to adapt them. But in this case, Apple did an awesome job, and hopefully after I kind of go through this section of the talk, you'll agree. So I'm just going to talk about examples of what we think are collection views with UIKit Dynamics and iOS 7. Talk about the APIs and how they fit together, and then show you a demo. There's a little bit of an assumption that you're familiar with collection views. I'm going to go over them really quickly. And also, obviously, what Sam talked about with UIKit Dynamics. But stop me with any questions. So just starting with UI collection view, I'm going to try to give a quick refresher of how that works. It was introduced in iOS 6, which I think is another interesting thing, is that this has been around for a while. Basically what it lets you do is display an ordered collection of views, right? Which isn't super interesting, right? We've had table views for years and years, so we were able to do exactly what this is saying. But the key thing is that you can define customizable layouts. And that's what sets collection views apart. So what does that mean as far as customizable layouts? Well, it lets you do all sorts of things that really weren't possible with table views, or much harder with table views. So a grid, for example, you could have maybe implemented a grid with a table view. Maybe you put, you know, multiple cells in each table view cell and manage all of that yourself. But anyone who's done that knows that it's kind of a pain. Or even just a horizontally scrolling, you know, collection of things in a line can be pretty difficult to do pre-iOS 6, before collection views. Collection views make that kind of thing very simple by allowing you to define your own layouts. You could even do things like a circular layout. There's a sample code from, I think, 2012, when collection views were introduced, that show you how you can arrange a collection of views, you know, in a circle, which is pretty crazy. You couldn't really do that very easily yourself without kind of rolling all that code yourself. Beyond that, you could just do just about anything you can imagine. So, like, really, it opens up a huge world of just crazy things as far as user interfaces go. So I think that's really cool. Matt Thompson, which probably a lot of iOS developers are familiar with, you know, said on NS Hipster that collection view is the new table view. It's that important because it opens up all these possibilities. I think that collection view with UI Dynamics is the new table view. And I'll kind of show you why, because I think it's going to really change the way we think about some of these user interfaces. So how is Apple using this? There's several examples in iOS 7. We don't obviously have the source code to those apps, but we can get a pretty good idea of looking carefully at the animations and the interactions to see how collection views and UIKit Dynamics are working in Apple's own apps. So kind of the definitive collection view example is photo gallery. And one of the reasons why I think this is a collection view, or why it probably is a collection view, is that when you're transitioning between, you know, years down to collections down to moments, the individual photos are like the same view. You know, you can see like that, well, you can't quite see it in the year view, but it's actually just adjusting the layout to move those cells around, which is another feature of collection views. The layouts are separate, and you can transition from one layout to the next, and it does animation for you. The other thing is to notice that there's sort of this bounciness effect, which very well could be done through UIKit Dynamics. So that's pretty cool. Another thing in iOS 7, which maybe generated some controversy, I don't know, maybe some people don't like this effect, but in messages, as you scroll through messages, as opposed to previous versions where sort of everything accelerated and decelerated at the same speed, you'll notice that each message sort of looks like it's attached to its own spring. And so as the message's view, like the collection view itself, comes to a stop, every message sort of like lags behind the previous and like, you know, hits its final resting place, which is a pretty cool effect and would be really tough to do without UIKit Dynamics. Now, you might say this could also be done with a table view, and that's probably true, but because of the way that collection views were really designed to work with UIKit Dynamics, I'm thinking that this is a collection view. Table views didn't get the same treatment, so table views sort of got the shaft when it comes to the integration with UIKit Dynamics. But that's okay, because a table view is really just kind of a special case of a collection view. So you're not really, you know, boxed in as far as that goes. So quick review of what a collection view consists of, just so we're all on the same page as far as the later examples. You have 3 types of views in a collection view: cells, supplementary views, and decoration views. So looking at the photo gallery app, the cells obviously are the individual photos. So a cell view is created for each data item in the data source, right? It actually represents the data itself. Then supplementary views, and it's always easy to get supplementary and decoration sort of confused, at least initially. Supplementary views are designed to display things about the data, sort of like metadata. In this case, the photo gallery is using that to tell you when those photos were taken and where that particular collection of photos are taken. So a lot like table view headers. Then there's decoration views. Now, decoration views are views that are part of, that are displayed in the collection view, but are for adornment purposes only. And adornment in iOS 7 kind of took a hit, right? Like, good old Johnny got his hands on the interface and stripped away all of that stuff. So there aren't really anything that we can easily identify in this interface as a decoration view, right? Because even the stuff at the top, that's part of UI navigation controller, and there's tab controller at the bottom. But that center portion, there's nothing there, right? Well, does anyone remember iOS 6 when, you know, we had these beautifully, you know, wooden interfaces, you know, fine grained leather and like graphite and all these awesome skeuomorphic designs, right? Remember this? This is iBooks from iOS 6 a few short months ago. Well, that bookshelf, if we were going to redesign this or implement this as a collection view, which it very well could have been, we don't know for sure. That bookshelf thing back there is a likely candidate to be a collection or a decoration view. So you don't see those too much in the current version of iOS, but hopefully in my example with UIKit Dynamics, I'll show you how you can sort of resurrect a good old decoration view for another purpose. So high level, just kind of what objects are involved with the collection view, again, so we can kind of get the background for how we actually go about introducing some physics-based stuff into our layouts. You have the collection view kind of in the middle, and on the left side you can see the data source. The data source provides views to the collection view, very similar to a table view if you've never done collection views. It's just asking you give me a view for this particular item of the data, and it's your responsibility to return that. The new piece is, or new for collection views in comparison to table views, is that there's this layout object, which is also attached to the collection view. And instead of providing or manipulating the views directly, you provide these layout attributes objects. And I've sort of made those as like little green dotted lines to indicate that really all those are specifications for where to position a view, but it's not your job to actually apply that specification to a view and move it around. The collection view does that for you. So this sort of division of responsibilities, I think, is really nice because you can almost think of the layout as like another data source, but instead of providing views, it's just providing measurements. And that really frees up the collection view to do all sorts of internal bookkeeping, memory management, tracking which views are on screen, and you don't have to worry about that. So how do you actually implement your own custom layouts? Well, the first thing to just bring up is that if you can avoid implementing your own custom layouts, you should. There are built-in layouts like the flow layout, which implement a basic grid, and you should definitely use those if you can. But if you're not going to, the methods that you have to implement are a little bit scary at first, but you basically subclass UI collection view layout and provide implementations for each of these methods, which represent the collection view asking your layout questions about where it should position specific items, right? So there's kind of one for cells, there's one for supplementary views, one for decoration views. There's also one that asks you what views are actually in the screen or in a given rect. So it's kind of your job to provide that code. Here's where UI Dynamic Animator really helps out if you're using UIKit Dynamics. UI Dynamic Animator has a bunch of utility methods that take care of this for you for each item that you put under the Dynamic Animator's control. So as you can see, these utility methods, items in rect, for example, can fulfill the contract that you're responsible for in your layout. And similarly for cells, supplementary views, and decoration views. So all you really have to do is create an animator and forward each of these calls onto the animator, and it takes care of the rest. One other key thing that you may have already kind of realized is that these little green boxes, these layout attributes, and I think Sam already mentioned this, these are the properties on a layout attributes that you can configure when you're just implementing a regular collection view layout. Well, if you look at focus on the bound, center, and transform, those are the three properties that are part of the UI Dynamic Item protocol. So layout attributes, just like UI view, also conforms to that protocol, meaning that you can create behaviors that connect attributes together. So I can take the attribute for a cell and create an attachment behavior to the attributes for another cell, or apply gravity to attributes. And when you start talking about it, it gets like, it's kind of crazy because it gets kind of super meta, because you're not even, you're so far removed from the actual views, which is what we're so used to sort of manipulating, like by setting up gravity on sort of this object that represents the measurements of a view in the layout. But once you get the hang of it, like, it's really, really powerful. So the picture kind of changes, right? Instead of just the collection view layout providing these attributes, the dynamic animator is really providing the attributes, and we're just setting up relationships in the animator between different attributes for each cell or decoration view. steps of actually implementing your own custom layout. We're getting close to actually making this happen now that we kind of laid the groundwork. So subclass, I guess step 0 is subclass collection view layout. And then when you initialize your layout, create a dynamic animator. There's a special initializer. If you remember from Sam's part, you initialize with a reference view, and that sort of sets out like, where the other views are going to live inside of the simulation. There's a separate initializer that inits with the collection view layout. So again, another helper method that Apple put in there to specifically make it easier to work with collection views. Then all you have to do is add behaviors to the animator with those layout attributes. And a good place to do this is in prepare layout, which gets called right when your layout is invalidated. So basically what you do is gather up all the things that you're going to display and add a bunch of behaviors to the animator. You could also do this when you're making updates to your collection view. So if you're inserting items to the collection view, that'd be another place to do it. Running low on time. OK, so 4 minutes. OK. So I do want to get to just the demo really quickly, but forwarding the layout attribute methods to the animator, and then basically just realize how awesome this is because there's so little code involved once you get to that point. OK, so tweet battle is the demo, and I'll just kind of jump into it, but it's kind of a crazy example of taking this to an extreme. And it's huge.
Command 3.
Jeez. It's still really huge.
I think Command 1 should get down to a more manageable size. I think maybe it's Command 3 now.
Yeah, I'm doing Command 1.
Oh.
I think it's 3 that you want to use the 50% one.
All right. OK, it's not going to get much smaller than that, apparently. I guess you could do, I don't know if that's a good idea or
Is
not.
it run okay on iOS or the iPhone Sims or iPad?
Select iOS 7.
Oh, did I?
I don't think that makes it smaller.
There you go.
No?
No?
It's better. See if it actually works in non-retina. OK, so what you're going to see here is that beam in the middle is actually a decoration view. And it's attached by its center to the center of the collection view. And that means that it can basically freely rotate left and right, right? This app is also listening for tweets, streaming on 2 different hashtags. So if someone tweets either these 2 hashtags, Team Adam or Team Sam,
Okay, I think Team Sam's this side of the
their avatar will be attached as a cell to the left side or the right side of the beam, and the beam can tip, right? So this is a collection view, which is kind of insane. Like, this looks just like some other, I don't know, crazy thing, but it's actually a collection view. And those items are just getting inserted.
Team Sam's totally winning.
Yeah. And I kind of added some angular resistance here, actually, so that it doesn't just like tip over right away. That's why it's kind of like slowly like falling over.
Yeah, Team Sam.
But so it's pretty cool.
Nice.
So just kind of out of for illustration purposes, I won't go into huge detail with the code, but the layout class there is like 163 lines, and most of that really is just about setting up those behaviors like I was talking about. And here's kind of that magic stuff where you can't really see. Can you?
At the top, you might need to slide over a little bit.
There we go.
Window.
Oh,
And drag the window over.
It's really annoying.
Is Tweet Battle on GitHub too, Adam?
It is.
Awesome.
Okay, so this is really just the coolest part, is that the animator that I created, I'm supposed to implement these methods, and all I just do is just return whatever the animator says. Whereas normally, if you're implementing that yourself, that can get pretty involved. Okay, very last thing is I did just kind of another test. Yeah, there's no end state. Of just like Android versus iPhone. And it turns out there's a lot of people tweeting this at any given point. But it's really awesome. And so it shows, like, I think another piece of this I wanted to show you is that if all goes well, this will eventually crash, which the best demos are the ones that are supposed to crash, right? And you can see it's really, like, bogging down.
Still going.
Come on. Wow. Boom. Yeah.
Time complexity of collision detection.
So that's actually, yeah, like the biggest thing, and in terms of, we're just about out of time, but just like in terms of limitations, it's really CPU bound, just doing all that simulation. And collisions are by far like the most expensive of the types of behaviors. So if you're trying to sort of like, figure this out, and if you're running into performance problems, looking at that is one option. The other thing is just limiting your data set size when you're in collection views. That's really important. There are ways to sort of mitigate that by only dealing with the views that are on screen, but it's important to realize that the system doesn't care whether things are on screen, and if the system that you're building should reflect things that are happening off screen, like if you have views that are attached to views that are on screen, it might mess up how, like, the effect you're trying to achieve, like by ignoring those. So
you don't have to use, or so if you're using Dynamics, you're using with a layout, you don't have to implement your own layout. You can use a flow layout as well, too, right?
absolutely, yep. So you can kind of just use that to sort of make tweaks about how the flow layout, transitions or.
Override all the default behaviors, right?
Exactly, yeah. It's pretty awesome. And hopefully you can use decoration views again. That's the other thing I think. It'd be fun. So, thanks everybody.